Hey everybody, welcome to another math help video. In this video we're going to do transformations of quadratic functions, lesson 9.2, part 2. We've already done a part 1 video where we learned how to shift things around, like left, right, up and down, what causes reflections, what causes stretches and shrinks. And here we're going to be doing some different kinds of problems that were from the same lesson. This one does not involve us moving stuff around really. Let me get to the first problem to show you what I'm talking about. Find the equation of this graph shown below. That's it. It's a quadratic function, that's important. And they've given us 2 points on it. Now, they've given us the vertex. They should give you the vertex on every problem, or otherwise you're going to have a rough time. Well, I mean, it's possible, but no, it's definitely rough. And then they've given you one other point. After looking through a couple of these problems, I found that the second point always seems to be one away from the first point, which will result in something A, helpful to us getting the problem done quicker, but B, not so helpful in case you actually ever don't have a point that's not right next to the vertex. But c'est la vie, let's do some math. I don't want to sound rushing on this video, but this is the second time I've recorded this because the first time I did it, I tried to figure out how to show you how to do it on Desmos, and it didn't work out at all, and I kind of wasted like 8 minutes of time, and it was gross, so I'm just like, redo the whole assignment. So this is my second time doing the assignment, so if I seem like I'm rushing, I apologize. Please feel free to pause and review and figure out what I was trying to explain. I will try and be thorough. All right, so the way we're going to approach these problems is we're going to first write down the vertex and the other point. I'm going to call the other point P. You don't have to call it P, but I'm going to call it P. And then our goal is we're going to fill in this formula. Y equals A x minus h squared plus k. Now, it's not really y, it's kind of f of x, like that's what they've given us on the problem over here. But I'm going to use y. The reason for this is because our goal is to write the stuff on the right side of this equation, but with a and h and k filled in, like their values need to be filled in. The problem is you can't just get them from these points, sort of. And by sort of, I mean this. The h and the k value actually are given to you automatically. They're part of the vertex. The x value of the vertex is h, and the k value is found from the y part of the vertex. Easy, right? A, you're going to have to do a little bit of work to find. This second point doesn't really give you anything besides just some random x value and some random y value. And we might use those later, but let's get to this first. Y equals a x plus 4 squared minus 4. So what did I do there? Well, what I did was I took the vertex, the -4 and the -4, and I plugged them in for h and k. Now you'll notice the k turned into -4, as it was, but the h turned into +4. The reason why is because the formula has x minus h. When you plug in a negative number, it's like plugging in a minus with an already existing minus, so it's like minus minus. So the appropriate thing to do would be to write the opposite of it. Just like when we were doing the one where we were shifting things around left and right, and a positive meant actually you need to go left, and a negative meant you actually need to go right. That's because this reversey stuff was going on there. So please make sure when you enter the h value, you're writing kind of the opposite of what the h value is, so to speak. Okay, from here we need to find the a value. So how do we find the a value? Well, you can't do that with all these other letters. Like, you can't solve an equation with 3 kinds of letters in it. So we need to do something about x and y. Well, that's what I mentioned this up here for. The p has an x value and a y value, so you're actually allowed to replace x and y with those values. So y becomes -6, x becomes -5, and the rest of the formula was the way it was. So basically I just took the y out and the x out and I turned them into their numbers that were from the second point. Now I'm going to simplify some stuff. So -5 plus 4 in this parenthesis becomes -1. -1 squared is 1. A times 1 is A. So basically what I did was I cleaned it up a little bit. The stuff next to A was simplifiable, so we made it -1, then we squared it, and it's 1, and anything times 1 is itself. So now we've got -6 equals a minus 4. Well, you got to solve for a. That's our goal. We need to know what a equals, otherwise we won't be able to make an equation. So plus 4, and I get -2 equals a. Yes, you got to do a little bit of equation solving here. Now, with that information, we're done. We have everything we need to fill out the formula. So see how this formula was y equals a x minus h and k? Y equals -2, because that's the a value we found, x plus 4, that's how we filled in the h the first time, that should be no different when we write our final answer, and then a minus 4 at the end. And that's our final done deal formula. And if you're sitting there thinking to yourself, man, is there an easier way to do this? Could I do it on Desmos? As I said a minute or two ago, nope, turns out you can't. Sorry. Oops. Oopsie doodles. Now what you can do is this. Once you've gotten what you think is the answer, you're welcome to type it into Desmos or a graphing device or whatever, and at least confirm it looks a little bit like what you're seeing on your graph here. Does it share the proper vertex? Yeah, -4, -4. Does it have a point at -5, -6? Maybe a little bit of dragging around here. Yes, it does. Okay, so you could graph it on Desmos just to see if you have it right. You could check. Might as well be sure you're right. That's how you would want to do it in a real test situation, right? Here's the problem, though. You won't know that this is what you need to type until you've done some work to figure out that this is what you need to type. You know what I mean? Let's look at a couple more. 3 more to go. Hey, we're 25% done with the homework, though. All right, next one. We got a vertex at -1, -5. And we've got an additional point at -2, -2. So let's fill it out again. So y equals, I don't want to write this every time, but I will write the generic formula first couple of times here. So y equals x plus 1 squared minus 5. Where am I getting those things? Remember, x came from the h value came from the vertex, the first bit of the vertex, so -1. Remember, we write the opposite, though. And then the -5 became the k value. Just like on the last problem now, I'll turn x and y into those numbers that came from the second point. And they're both -2, so that's, I guess, convenient, question mark, maybe? I don't know. So I'm going to fill in x with -2 and y with -2. And the result is a times -1 squared minus 5. And just like the previous problem, when you square -1, it becomes regular 1. And a times regular 1 is a. And now we've got a little equation to solve here, which is done by adding 5 to both sides. And I get 3 equals a. And now I have all the pieces. I had x and k from the vertex, and I now just solved for what a equaled. So now I have everything I need. X plus 1 minus 5. Again, I'm using the same stuff I did from the bottom of this first column. I just now have an a value, so I'll add that into it to finalize my equation here. 3x plus 1 squared minus 5. If you watch the lesson video actually took this further, because the problems in the lesson video said put your answer in standard form. That would be a little bit more of a process. Like I'll show you on this one, I guess. I'll take more time. I just deleted my answer. Booey. There we go. Put that back. Just so you guys can see, on the lesson, we took this further by expanding it, like we did 3x squared plus 2x plus 1 minus 5, 3x squared plus 6x plus 3 minus 5, 3x squared plus 6x minus 2. This is also an acceptable answer to this problem right here that I'm doing. This is the standard form. I wrote my answer in vertex form. Alex doesn't care if you write it in vertex form or standard form, but if you're going off the lesson video and thinking to yourself, wait, wasn't there more to do here? Yeah, there was sometimes. So you could do more. Alex doesn't care if you stop right here and call it a day. This is the right answer. I'm telling you this is the right answer. I'm pretty sure it's the right answer. Oh, geez, I hope it's the right answer. I don't have a perfect track record, so being wrong doesn't matter to me anymore. Notice I switched it to standard form, and it was also okay with that. So if you feel like you want to do the extra steps to put it in standard form, be my guest. I did skip kind of a step here, so I guess I should show you. How did it go from x plus 1 with the squared on the outside into this stuff on the inside here? Because I did x plus 1 times x plus 1, and then I foiled it, and I got x squared plus 1x plus 1x plus 1, and this stuff became x squared plus 2x plus 1. Okay, so if you're like, whoa, that's a lot of extra stuff, I don't want to do it. On Alex, you don't have to do it. Who knows what you'll see in real life? Yeah, you might need to put it in standard form, which would require a little bit extra work, All right, we will do another one, and I will continue to speed up the process. Oh my gosh, I've been waiting for one of these. Yes! I'm so glad. Every single problem, the first time I did this video, and on these first two problems, the first point, the vertex, was just 1 unit away from the other given point. But this time it's 2 units away. How do I know that? Because this is 2 and that's 4, so that's a 2 unit jump. Usually it's been like 2 and then 3, or 2 and then 1. Finally, 2 and then 4. This is important. I was hoping to get this because if somebody gets this on their homework, I don't want them to be sad and confused. All right, let us begin the process. I was going to skip some stuff, but now having seen the problems a little bit different, I'll write it out a little more thoroughly. So y equals a, x minus 2 plus 4. So I'm using the 2 and the 4 from the vertex to fill that in. And then on the second half, we're going to fill in the x and the y. So 12 for y, a, 4 minus 2 squared plus 4. This is why I was happy that it's 2 apart, because on the last two problems, we got like 1 or negative 1, and then we squared it, and 1 squared is 1. But here, I'm going to get a 2 squared and 4. And this is going to be a times 4 plus 4. And since it was a times 1 in the past, I just wrote a because a times 1 is a, but a times 4 is technically 4a. So now I have to solve this, and I'm going to solve it slightly different from the last ones. The last ones I was adding and subtracting stuff. Here I'm going to subtract 4. That'll give me 8 equals 4a, and I get the fun of doing one extra step called divide by 4 on both sides. So you might need to do that, just so you guys know. And I'm glad I got to show it to you on at least a problem here. So we got 2 for a. Hooray, everything's here. I can put the problem together. Y equals 2, x minus 2 squared plus 4. Again, the negative 2 and the 4 came from the vertex, and then the 2 was what I got for when I solved out for a or whatever. And again, I could put this in standard form. I'm choosing not to put it in standard form here. I'll standard form on the fourth problem just for you guys that like to be all standard formy or whatever, I guess. Next. Now you'll notice each time I've done these problems, I've put in the h and the k, and then on a second line I put in the x and the y. You could do it all at once. I'm going to do it right now. I'm not even going to put the basic formula. I'm just going to plug everything in. Y equals a. That's the only thing I don't know. And then x minus h squared plus k. So I filled it all in at once. I put the y value, I put the x value, I put the h value, but remember it's opposite, so I put minus 1, and then I put the k value. So if you want to just start by just writing all that at once, yeah, you totally can. Save a little bit of time, I guess. I just think it's safer to take your time. So I get 1 squared, which is a times 1 plus 5, and a times 1 is a. I'd write the next line, but my head's going to get in the way. Boop. We'll take it up to the top here. Let me write that again. 2a plus 5. Okay, minus 5 on both sides. You get 3 equals a, and your formula is good to go. So we're going to write y equals 3, x minus 1, because that's the x value from the vertex, plus 5. Terrible 5. Well, okay, we'll leave it like that. Looks kind of like an S, but it's not. It's a 5, I promise. So on this last one, I tried to skip as much work as possible because, I mean, I feel like what I wrote on this one is at least what you'd have to do to solve the problem. So you could instantly take the vertex and the point and just plop them all into the generic formula and work it out to find a and then write your answer. Now, I did promise that I wouldn't stop there. That could be the end of the problem. But I did promise that I would show you how to get this in standard form if you want to be a standard formie. So first thing I'm going to do is this. I'm going to do x minus 1 squared off to the side, which will give me, do a little foiling here. Foiling, question mark? Okay, so I'll get x squared minus 1x plus 1. And so what will happen is this will come back as 3 x squared minus 2x plus 1. That's what all the insides turn into when you square them. You get 3x squared minus 6x plus 3 plus 5. And then you get 3x squared minus 6x plus 8, because you can combine that 3 and 5 together at the end. So here I will write as much, 3x squared minus 6x plus 8. Uh-oh, did I do something wrong? Hold on. Calculating and thinking and thinkulating and calculizing. What in the world? This is what I get for trying to be a cool guy and do a little extra work or whatever. Okay, hold on. Hold that thought. What did I do? X minus 1 plus 5. I've got it, and I know exactly what I did wrong. The problem is I did it so long ago that it's hard to show you what I did wrong. Late at the end of the problem, when I was solving this, I subtracted 5 on both sides and I wrote 3. It was supposed to be a negative 3. That is 100% my mistake. So we're going to make that a negative 3, a positive 6. Hold on, let me write some stuff here. Negative 3, positive 6. That means actually that this shouldn't have been. Let's just erase that. This shouldn't have been a negative 3. Oh no. By the way, this is not how you erase stuff on Paint. I'm aware of that. I just want to do it in the most obnoxious way possible, apparently. Anyways, this will make a +2. So some things went wrong here. Oops, that was my mistake. My bad. Even if I had written the answer in vertex form, I would have been wrong because, let me see if I can back up enough. Backing up in time. Oh, I can't back up in time any further than that. Oh, drat. Well, we're gonna cut that. But here was the point in time where things didn't go great. When I had 2a, and then it said +5, I minus 5 on both sides, and I was supposed to get negative 3 equals a, and I accidentally wrote regular 3. Be careful. This is what you get for going fast, man. See, just a prime example of how to not go fast. All right, I'm hitting submit on this guy. All right. That was quicker than my first time making this video. Hopefully not so quick that it was confusing to you. I mean, don't get me wrong. This is not the easiest thing to do. Creating an equation is not like an easy algebra concept. And again, the process for making equations depends on what kind of equation you're trying to make. In this case, we were trying to make quadratic equations. So what we used our vertex. We used x and y from our additional point, and we use that to backwards engineer, let's say, the value for a, this like number multiplying out front of the parentheses in our vertex form. And then using a and h and k, we were able to find the values that made it work. So, for example, on number 1 and 3, I left it in vertex form. So I wrote the h and the k from the vertex, and then after plugging some stuff in and working it out, I found an a value that worked. On problem 2 and 4 a little less successfully, I, instead of leaving it at the vertex form, multiplied some stuff out and put it in standard form. You don't have to do that for the homework, but it was something that was shown to you on the notes. So it's good that we practice a little bit here. Same process though. I take my h and my k, I plug them in, I work out what a equals, and if you so wish, you could stop the problem there, or you could work it out more to get it into standard form. That is why this assignment was only 4 problems. They're meant to take a little while, so take your time, get some help. Please seek out me or any other teacher if you want some of that help. We're here to get you up to date on this. This isn't going away at the end of this year. You will need to create more formulas and more equations throughout all of math until you don't have to do math anymore. So, get some help now. All right, that's my rant. And I'm done making this video, and I will see you guys on the next help video. Goodbye.